Okay, chapter 9, electrons in atoms and the periodic table. Makes it sound like there's electrons in the periodic table, which there are, but that's not what the title is meaning. Okay, you guys heard of the Hindenburg? They still talk about that in history class? This is an picture of the Hindenburg back in 1937. So this is a dirigible, a blimp, and it was filled with hydrogen. So a blimp filled with hydrogen. They used hydrogen because it is the lightest gas and it has the most buoyancy in the air. So they made it across the Atlantic, but as they were landing, something happened and it burst into flames. There were 97 passengers aboard, 36 of them died. We did learn something from this, and people don't fill blimps with hydrogen anymore. It's obviously not a good idea. So why are we even talking about this? Well, a chemistry question is, what makes hydrogen so reactive and so flammable? Why does hydrogen do that? Helium balloons also float, but they don't burn up like this. What's the difference? We fill modern blimps with helium. It's very inert. It does not react. It will not combust. In fact, there are no known compounds of helium. It just doesn't react with anything. So what we're going to learn about in this chapter is a model that explains why helium doesn't react with anything and why hydrogen will react with almost anything. Are there other elements that are as reactive as hydrogen? Yeah, there are some other elements that are very reactive. We see that in several of the other group 1 elements, lithium and sodium, very reactive. There are other elements that are inert, like helium. Helium is over in group 8 in the periodic table, group 8A, the noble gases. And the other noble gases are also notably inert, such as neon and argon. So we've seen patterns in the periodic table. Models and theories help us to explain why those patterns are there. We're going to look at 2 important models, the Bohr model and the quantum mechanical model. And these are going to explain what's known as the periodic law. When the elements are arranged in orders of increasing atomic number, certain sets of properties recur periodically. That's why it's called a periodic table. So the group 1 elements have a lot of characteristics in common. The group 8A elements have a lot of properties in common. That's the periodic law. And quantum mechanics and the Bohr model are going to help us understand why that happens. We're going to be looking at the electrons and what they're doing. Quantum mechanics is going to bother you, and I'm sorry, but it bothered some notable scientists as well. This is a picture of Niels Bohr, and this is a picture of Erwin Schrödinger. And they both worked on quantum mechanics, and here's some quotes from them. Niels Bohr said, "Anyone who is not shocked by quantum mechanics has not understood it." Schrödinger said, "I don't like it, and I'm sorry I ever had anything to do with it." And Albert Einstein, you've heard of him. Albert Einstein disliked it as well, said God does not play dice with the universe. He tried until his death to disprove quantum mechanics, but couldn't do it. So it is disturbing in a way, but we have to go over it because it's foundational to modern chemistry. It's the basis of the modern periodic table. It helps us to understand chemical bonding. And because of this model, we can discover new uses for existing substances, and we can also discover new substances and new uses for them.